Hi, third graders, it's Mrs. Burke. Thanks for checking in today. You've been doing a lot of great work in math around perimeter, and today we're going to introduce a new topic of area, which is related to perimeter. So when we learned about perimeter, we were finding the distance around the outside of a figure. And today we're going to focus on area, which is not going to think about the outside of an area, but it's going to focus on the inside of an area. So to be more specific, area is the measure of the number of square units that are needed to cover a surface, or what's on the inside. So that square units is important to note. Basically, we're going to take a figure and we are going to divide that figure up into different squares that measure the same size, and count up how many squares actually fit inside that figure. So before we do that, there are some rules, okay? So I'm gonna show you just two examples of what it might look like. We might have to find out how many squares are inside this figure, or how many squares are inside that figure. Maybe how many squares are inside a rectangle or a square. And sometimes our squares might be different sizes. So here, they're about 1-inch squares, where here, the squares are much tinier. I'll show you. So maybe you have to find the area of that figure and you'd be using squares that are that size. Okay, but there are some rules about these square units before you start. Rule number 1, the units must be squares. We are not going to be covering the inside of any of these shapes with rectangles or circles or triangles, or even, well, let's use some squares and then some rectangles. No, they all have to be squares when you're measuring the inside. Next, your square units cannot overlap. And last, you're not allowed to have any gaps in your measurement. And I'm going to show you what some of these rule breakers would look like, okay? So let's take example A. What do you notice about example A? Do you think you see a broken rule here? Example A has a square here and a square here, and this is a square too. But then I have a rectangle, and a rectangle. I am not allowed to use those rectangles when I'm finding the area. So yes, there are 6 shapes inside this square, but these are not all square units. So that does not have an area of 6 square units. So that would be a rule breaker. Cross it out. Okay, number 2. They took the same figure and they put squares inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this student believes that this figure has an area of 12 square units. But there's a problem. What do you think? There are gaps or spaces. Look at all this area in here that doesn't have a square covering it. That's a rule breaker. You're not allowed to have those spaces. So this does not have an area of 12 square units. That's wrong. Let's look at this next weird one. It seemed to start off good. Here, let me just, so it's a little more clear to you. The pink is the rectangle that they want us to find the area of. So look, they started with some squares, but look at the square 5. See how it didn't really fit in? It's kind of hanging off there. And same with square 10, it's kind of hanging off of my rectangle. And look down here, I had 16, 17, 18, 19, 20. This student knew I can't have gaps, so they put another tile, but the tile is hanging off of my rectangle. Well, guess what? That's breaking a rule. It cannot overlap. It can't fall off the paper or touch other squares. So this does not have an area of 25 square units. Let's look at the last one. All right. It's telling me it has an area of 16 square units. Well, it used all squares. I don't see any gaps. None of them are overlapping, and all the squares are the same size. So guess what? This does have an area of 16 square units. It doesn't break any rules, so I can use it. 16 square units. So we're gonna do some practice ones and some strategies about how you can find area today. All right, so let's start with these figures I drew on here. Okay, and if I was in my math room or you were in your classroom, we'd be having our tiles out, but I know that when you are in your house, chances are you don't have extra math tile manipulatives laying around. I just drew this on a piece of paper using a ruler. I just kept tracing squares and then like that, and I stuck it in a sheet protector. So now I can go over and over using the same paper without having to keep drawing a million templates. So this is an option for you if you want. So I'm noticing I used all squares. I don't have any overlapping, and I don't have any gaps. So now I'm in charge of finding the area, which means I'm going to count the number of square units. How many squares are needed to cover the entire inside of this figure? So here's how I like to do it. I like to actually put a number inside each square to tell me that I've counted it. So I'm going to count this. Well, let me use a marker that works. Okay, so this would be square 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It took 12 square tiles to cover this entire inside of the figure. So I can say that this has a measure of 12 square units. Okay? Now let's say more specifically, I knew that my tiles were all 1 inch in length and width. Let me see if I can find the area of this shape. I'm gonna number each of them. So this would be tile 1. This would be 2 square inch tiles, 3 square inch tiles, 4 square inch tiles, 5 square inch tiles. So this has a measure of 5 square, and since I know the units are inches, I could say 5 square inches. Okay? Now I'm gonna do one more, and I wanna see if you can tell me what the area would be. This is a fun little game you can even play with your sister or brother. Okay. So I'm gonna give you 30 seconds. I know it's kind of hard because you can't draw on my figure, but even just slowly count how many, and I'm gonna tell you, we'll say that each tile is a square meter. So how many square meters is the area of this figure? Okay, let's see if our answers match. 1 square meter, 2 square meters, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the area of this figure is 14 square meters. Okay, great job. Now, I'm gonna draw another shape for you. And you should be able to quickly recognize what this shape is called. What do we call that shape? This is a rectangle. Now you have a few options when it comes to a rectangle. Rectangles are special here because as opposed to this other figure I'll draw below, we'll call this A and this one B. If I look at figure A, I actually feel kind of lucky because it's nice and equal. Here I have 2 rows and each row has 4 tiles. Here I have 2 rows, but this row has 5 tiles and this row has 4 tiles. So figure B is going to require me to count each one individually. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where figure A, because it's a rectangle, I have an option. I can take everything I've learned so much about these last 2 or 3 months with multiplication, and I can use that to help me find the area. We're going to call this an area model, okay? So this is what I'm going to do. First, I'm going to count how many rows do I have. Remember, rows go across. 1 row, 2 rows. So I have 2 rows of, and let's count how many tiles are in each row. 1, 2, 3, 4. 2 rows of 4. So I could say 2 rows of 4. If I were to write that as multiplication, that's right, 4 in every row times 2 rows is 8. Or I could do, remember 2 rows of 4, so I could do 4, that's row 1, plus 4, that's row 2. What is 4 plus 4 for those of you who know your double facts? Correct, 8. And what's 4 times 2? 8. So when you see a rectangle or a square, you can use repeated addition or multiplication to come up with your area as a shortcut. And if I wanted to just count tile by tile, I still can. I'm going to check. 1, 2, 3, 4, 5, 6, 7, 8. So this strategy will work no matter what shape my figure is. But in order to use the multiplication or repeated addition, that's only going to work, we'll call it the area model, it's only going to work for rectangles and square figures. Okay, so let's try another one. Here's my figure. And what shape does that look like? That's right, it's a square. So I have 2 choices. Well, I actually have 3 choices, but 2 choices. I can do repeated addition, which means I have a row of 4 plus a row of 4 plus a row of 4 plus a row of 4, which is going to equal 16 square units. Or I can take all my multiplication knowledge and I can practice my basic facts and I can say 4 rows of 4 tiles, 4 times 4 equals 16. Okay, so the area would be 16 square units. And to make sure I'm right, I can count each square individually, each tile. Okay, and I have 16 total. All right, I'm going to give you one to try. Okay. So how would you solve the area of this figure? Okay, let's see. So because it's a rectangle, I'm allowed to use my area model strategies, which is repeated addition or multiplication. So let me try both. First, let's think about repeated addition. I have 3 rows, and every row has 2 tiles. So I could do 2 plus 2 plus 2. There's 2 in 3 rows. Row 1, row 2, row 3. All together, that's going to give me 6 tiles. I could also say, a row of 2, a row of 2, a row of 2. So I have 3 rows of 2, which is 6 square units. And finally, my tried and true, never let me down, I can just count. 1, 2, 3, 4, 5, 6 square units. Okay? Now, one last thing I want to go over. Let's say they want me to model a figure that has a certain area. Let's use the number 12. And it wants to know how many different ways can I use an area model to show 12 square units. So I'm going to want to think, what multiplications or repeated addition will give me a sum or a product of 12? So I'm thinking of my math facts. I've been practicing since I've been home. I got my flashcards. I look at them every day for at least 5 minutes. I know 12, 6 times 2, or 2 times 6. So I'm going to show that. 2 rows, 1, 2, of 6. 1, 2, 3, 4, 5, 6. That equals 12 square units. Or I could have drawn it this way. Let me do 6 rows of 2. So this is 2 rows of 6. Let me do 6 rows. So 1, 2, 3, 4, 5, 6 rows of 2. That's also going to equal 12. And maybe I heard some of you knew another math fact. What's that? 3 times 4? Yeah, I thought so. So watch. I could also do 3 rows of 4. So here's my 1, 2, 3 rows. 1, 2, 3, 4. Here, this would be 3 rows of 4. So all of these figures here have the same area, even though they look totally different. This is a long and skinny rectangle. This is a short and long rectangle. This is kind of like fat and wide, however you want to describe it. But they all have 12 square units of them, so they're all equal areas, even though they look different. The important thing is, when I count the square tiles, they're going to have 12 in them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they may look different, but it doesn't mean their area is different. It all matters how many square tiles you count. Okay? So, good luck with your area work today. Take your time. Use a few of the strategies. Practice repeated addition. Practice the multiplication. Practice just counting 1, 2, 3, 4, 5, 6. The more you practice and the more strategies you get familiar with, the more comfortable you'll be. Okay? So have a great day, Stewart School, and I look forward to seeing you again soon. Take care.